Students, you must be knowing that for a spontaneous process, we do not need to do some external work. That means a spontaneous process happens on its own. A spontaneous process happens on its own, such as falling of this marker. It is happening on its own. So falling of marker is happening on its own. So this is a spontaneous process. But if we want to take it upwards, then we need to apply support continuously. So taking this marker upwards is a non-spontaneous process, but falling of this marker is a spontaneous process. So keep it in mind, any process that happens on its own is a spontaneous process, whereas any process that needs constant external support is non-spontaneous. Alright. So how we are going to understand that? In technical terms, if I tell you, for a spontaneous process, delta G must be negative and delta S universe must be positive. Alright. So ultimate thing is delta G negative. Alright. So let us see in how many cases we can have delta G negative. So the basic formula you need to remember is this. The basic formula you need to remember is this: delta G equals to delta H minus T delta S. So for spontaneous process, we want to have delta G negative, right? We will have few cases over here. Let's see delta H and delta S. So what are the conditions we are going to have a spontaneous process? Let's see. If we have delta H as positive, that means the process is endothermic. Delta H positive means the process is endothermic, and delta S is also positive. That means entropy is increasing, right? So here you put plus and here delta S is plus. So plus into minus is minus. So this is minus and this is plus. So to get overall value negative, what must be there? This minus term must be bigger than a positive term. So T delta S should be greater than delta H. That means temperature should be greater than delta H by delta S. At this temperature greater than delta H by delta S, process will be spontaneous. Process will be spontaneous. Alright. And below the temperature, the process will be non-spontaneous. Next, if you have enthalpy change positive and entropy change negative, alright, that means the process is endothermic and entropy is decreasing. Delta S negative means entropy is decreasing. Now, how we can say it is a spontaneous or non-spontaneous? Check the value of delta G. Delta H is positive, this is positive, and this is negative, delta S is negative. So negative into negative will be positive. So this fact term is positive, this is positive. So delta G can never be negative. That means if endothermic process entropy change is decreasing, then it will be a non-spontaneous process always. So non-spontaneous always. Non-spontaneous always, right? Next case, we take this negative and we take this negative. Now what will happen is delta H is negative and this is negative. Negative into negative is positive. So this term is positive and this is negative. So delta H has to be greater than T delta S. So delta H has to be greater than T delta S. So delta H greater than T delta S. So at what temperature? At temperature below delta H by delta S, the process will be spontaneous. At temperature below delta H by delta S, process will be spontaneous, and above this temperature, process will be non-spontaneous. Alright. So temperature below delta H by delta S, process is spontaneous, and above that it is non-spontaneous. In which case, when exothermic process and entropy is decreasing. The final point is I take delta H negative, that is exothermic process, and this is positive, right? So negative into positive is negative, delta H is negative, so this is negative and this term is also negative. So overall delta G value will always be negative. So in the final case, when this is negative, this is positive, delta H is negative, delta S is positive, the process will be spontaneous always. I hope you agree with me. All right. So this is how we can predict a process is spontaneous or non-spontaneous. All right. And we have few more formulas, such as there is another formula which we have already studied, that delta G naught equals to delta H naught minus T delta S naught. Not means the process has been happening at the standard condition values. Standard conditions in thermodynamics are 298 Kelvin temperature and 1 bar pressure. So any process happening in these conditions is called a standard process. Similarly, there is another formula called, that is delta G equals to delta G naught plus RTL and Q. At equilibrium delta G equals to 0, at equilibrium delta G equals to 0 and Q equals to Kc or Kp, equilibrium constant. So then you will have delta G naught equals to minus RT ln K. K is equilibrium constant. So you can have this relation for your calculations. A relation between standard Gibbs free energy change and equilibrium constant. So from there you can calculate equilibrium constant as well. So this is it for now.